Welcome back to another video. In this video, we're going to talk about radioactivity. Now, in the last video, we talked about the atomic structure, that the atom was made up of protons, neutrons, and electrons. Okay. Now, radioactivity was discovered quite by accident back in 1896 by Henry Becquerel, who found that the uranium salt placed in his drawer could darken the photographic film, even though the light couldn't get to it. So he found that there was an invisible radiation coming from the uranium salt. And today we know much more about this. We know that there are three types of radiation that is emitted by radioactive substances. And these are alpha particles, beta particles, and gamma rays. So first of all, talking about alpha particles, now they are positively charged helium nuclei. Now helium nucleus is made up of two protons, two plus charges, and two neutrons, which are neutral. And it's a large particle, and it produces a lot of ionization. Now, I explained what ionization is in the last video, but later on I'll explain it again to show you what ionization is. Ionization means when the alpha particle goes and hits an electron in the atom, it removes that electron from the atom, and the atom has got one less negative charge. It becomes positively charged. And some atoms, when they gain electron, they become negatively charged. So it can produce ions, okay, just by colliding with them. And because alpha particles are very heavy, they can go through the atoms, they can collide with the atoms, lots of atoms, and produce a lot of ionization. So its ionization power is very high. Now, the next thing is, if you put an alpha source and a detector, and if you put a sheet of paper in the middle, you'll find that most of the alpha particles will be absorbed. So it gets absorbed very easily, even with a sheet of paper, or the human skin can absorb it. So exposure to alpha particle is not that dangerous. Now, the fourth property is it's deflected by electric and magnetic fields. Because it has a positive charge, it will be deflected towards the negative plates in an electric field, and it's also affected by the magnetic field. Now, the other type of radiation that comes from the atom, from the nucleus of the atom, is beta particles. Now, beta particles are negatively charged electrons of very high energy. Now, how are they different from normal electrons? The normal electrons in the atoms that goes around the nucleus, beta particles are different from that in the way that they come from the nucleus of the atom, and they carry a lot of energy. Their speed is almost close to the speed of light. Okay, they travel very, very fast. They are highly energetic, they're highly penetrating, and they can easily pass through your skin, through a sheet of paper. And it takes about 3 millimeters of aluminium to absorb beta rays or beta particles. Now, beta particles, they also collide with the atoms and knock off the electrons from the atom and ionize it, but not as much as alpha does. Okay, its ionization power is medium. It's not as high as alpha. And we already said that it can be absorbed by about 3 millimeters of aluminium. It is also deflected by electric and magnetic field. Because it is negatively charged, it will be attracted towards the positive plate, okay, or it will be affected by the electric and magnetic field. And the third one, type of radiation that comes from the nucleus, is known as gamma rays. Now, gamma rays, we already know from the electromagnetic spectrum. When we talk about visible light, ultraviolet, X-rays, gamma rays, that's part of the electromagnetic spectrum. They're not particles, they are waves of very, very short wavelength. Even though we can regard them as a photon, or as a particle as well, but they have a very, very short wavelength. They have a very high energy, and they are highly penetrating. They can go through anything. They can go through a sheet of paper very easily, through a 3 millimeter of aluminium, no problem. It needs very, very thick blocks of lead in order to absorb it. And they produce less ionization as they go through the materials. And they are not affected by electric or magnetic field. I've written E and M for electric and magnetic. Because they don't have any charge, okay? They are electromagnetic waves, and they're not affected by electric field or magnetic field. Now, in this video, I think I'll just explain to you a little bit about how ionization is caused, okay, so that you will understand the process. Now, if we have an atom, okay, the nucleus is there, there's an electron going around it, that's negatively charged, the atom is neutral. Okay, the number of protons and the number of electrons is equal, they balance, so the atom is neutral. Now, when an alpha particle, alpha, it could be beta or gamma, when they come and it strikes the electron, it knocks the electron out of the atom. Now, the atom will be left with one less negative charge. That means it will have one extra positive charge. So this becomes, the atom becomes a positive ion. And the electron that has been released becomes a negative ion. Okay, so it produces ion pair, positive and negative ions. And that is how, that's what ionization is. And also absorption. Now, when we talk about alpha particle, it can go and hit lots of atoms, okay, and ionize them because it's got a very high ionizing power, produce lots of positive and negative ions, and its range through the air. The alpha particle is only a few centimeters, 4, 5 or 6 centimeters. Now, beta particles, because they don't collide with the atoms as much, their range is much greater, like 15 to 20 centimeters in the air, and they produce less ionization. And gamma rays, that produces less ionization. Okay, in the next video, I'll talk about more about how these particles, where they come from, and how what happens to the atoms, okay, in the radioactive decay.